Today, our topic is the complex number. Now, before we start about the complex number, there is another term. That term is very important and connected with the complex numbers, that is known as the imaginary number. Now, suppose we are starting with an quadratic equation. The quadratic equation is like that: x square plus 1 is equal to 0. Or suppose another quadratic equation like x square plus 4 is equal to 0. Now, when we are solving this, suppose x square is equal to now minus 1. So if we want to find out the value of x, then that it is becoming plus minus square root of minus 1. Same as here, that is x square is equal to minus 4. So that means when we are finding the value of x, that is plus minus square root of minus 4. Now that minus is leading a problem, because we cannot find out the square root of any minus or negative integer. So that means the real number is not always sufficient, or any type of negative integer is not also sufficient to calculate something. That's why the necessity is the mother of invention. Like that means the born of imaginary number is there. That means what is imaginary number? In that case, the imaginary number means is a very small I. That is called the imaginary number. What is that imaginary number? Now here, to find out the solution of such that equations like x square plus 1 or x square plus 4 is equal to 0, the imaginary number is important. And about 400 years ago, the mathematicians proposed the introduction of the imaginary number, that is small I. Now, what is the property of that particular imaginary number? The property of that particular imaginary number is that I square plus 1 is equal to 0. That means we can write from here I is equal to minus 1. I square is equal to minus 1, or I is equal to square root of minus 1. Here that comes. That means I square is equal to minus 1 and I is equal to square root of minus 1. So where we are getting that particular square root of any negative integer, we are thinking about the imaginary number. That square root of minus 1 is equal to I, and we call it as a square root of minus 1. You can think. So some example like, suppose square root of minus a. So it can be written as minus 1 into a. So it can be written as minus 1 means I square into a. So we can now square root the I square. So it is becoming I of square root of a, where a is any positive real number. That means positive. It must be positive. The a value of a. Suppose another one with a number -9. So it can be written as same I of square root of 9. That means 3i. I am once again defining it. That one can be written as -1. That means I square into 9. So I square into 9 means I square into 3 square. So it is becoming 3i whole square, its square root. So it is becoming 3i. Same as directly we can write out -36. That means 6i. Okay. Same as suppose square root of -12. Here that 12 has no particular square root. So it can be written as I square into 4 into 3. So we write down it I square into 2 square into 3. So it can be written as 2i square root of 3. So simply from the very first equations, that where that one x square is equal to -1. So we can write it here x is equal to square root of -1 or I. Here also that can be written as 2i. So x is equal to 2i. So in that way, the imaginary number is used in the complex number. Yet now we have not proceed with the complex number, but imaginary number is the integral part of any type of complex numbers. So once again, we are proceeding to the powers of I, the discussion on I, the powers of I. So before we start, once again, for every non-zero real number, that is suppose our B, for every non-zero real number, suppose that is B, that IB or 2i or 3i like that, or BI is a number whose square is -b square. Because if we square it, we are getting I square b square. So I square means -1 into b square or minus b square. And that for b not equal to 0, that IB is called a pure imaginary number. Why not b equal to 0? Suppose we are writing I into b. So if b is equal to 0, that means the result is becoming I into 0 or 0. But that is not an imaginary number, because here the number is representing the value 0. So that's why b must not be equal to 0. So we are proceeding to the powers of I. As usual, from the very first one, any number to the power 0 is equal to 1. That means a to the power 0 is equal to 1. So in that case, we can also write I to the power 0 as 1. Okay. Next one, I to the power 1. As usual, it is equal to I. Next one, I square. I square is equal to -1. We know it. Now I cube. I cube means we can write it as I square into I to the power 1. That means I to the power 2 plus 1. So that is I to the power 2 into I to the power 1. Now I to the power 2, that means already we have -1. I to the power 1 is equal to I. So we can write I to the power 3 or I cube as I. Okay. Sorry, minus I. Because -1 into I, so minus I. Last one here, another one, that is I to the power 4. I to the power 4 means I to the power 2 into I to the power 2. So that is -1 into -1. That means 1. Once again, I am writing here something. For the very first one, it was I. For the second one, it was -1. That means when we have the power 2, we have the power 3, it is -I. When we have power 4, we have the value as 1. Let's proceed with next powers or more powers. Okay. So already we have up to I to the power 4. So I to the power 5. So it can be written as I to the power 4 into I to the power 1, or the value is I to the power 4 means 1 into I. I to the power 6. So it is I to the power 4 into I to the power 2. So that means I to the power 4 means 1, I square means -1. I to the power 7, that means I to the power 4 into I to the power 2 into I, or I to the power 6. That means it can be written as -I, because check here, the first one I to the power 4, that means 1, I square means it is -1, and the final one is simply an I to the power 8, it can be written as I to the power 2 whole to the power 4 into 1. That means nothing. So it can be written as I to the power 2 means -1 whole to the power 4 or 1. So once again, check. When we have power 5, the value is I. When we have power 6, the value is -1. When we have the power 7, the value is -I. When we have the power 8, the value is 1. I -1 minus I 1. I -1 minus I 1. So that means the values repeat in cycles for 4. For every fourth power, the values repeat. So according to this pattern means that is I -1 minus I 1. The values repeat for every fourth power, or in the power of fourth. Okay, so we can simply write another one thing here from, that is I to the power 4 into P is equal to 1 for any P, Q or something that is belongs to the real number integer. That is, we have I to the power 4 to the power P. So that is 1 to the power p, like that is 1. Okay, so how to find out a normal value of any imaginary number? Suppose I to the power 38. So it can be written as I to the power 38 means 36 plus 2. So it can be written as I to the power 4 into 9. 4 into 9 means 36 plus 2. Or we are writing that is I to the power 4 to the power 9 into I square. I to the power 4 means 1. So 1 to the power 9 into I square means minus 1. So the value is minus 1. Same as, suppose next one, that is I to the power 15. So that is I to the power, suppose 12 plus 3. So that is I to the power 3 into 4 plus 3. That means I to the power 4 to the power 3 into I cube. So that one 1 to the power 3. Now what is the meaning of I cube? Check. I cube means minus I. So we are writing that I cube as directly minus I. So it one is becoming minus I. Next one, suppose I to the power minus 6. Now the power is in negative. So what happens? So here we are writing it as I to the power minus 8 plus 2. That means to the power minus 6. So it can be written as minus 4 into 2 or minus 2 into 4. Okay, into I square, or moreover we are writing it as I to the power 4 to the power minus 2 into I square. So it can be written as 1 to the power minus 2 into I square means minus 1. Now 1 to the power minus 2, that means simply we have 1. So that is with multiplication minus 1 gives us the minus 1. Final one is very important. Here we have 1 divided by I. 1 divided by I. So here we are writing 1 divided by I into another 1 I has been taken in the numerator. So another 1 I has been taken in the denominator. 1 by I into I by I. So the numerator is now 1 into I and the denominator is now I into I. So I by I square. So that one is equal to I divided by minus 1, or simply which we can write as minus I. So here look at the main thing, that 1 by I can be written as minus I. Okay, so always remember one thing, I and minus I are the reciprocals of each other, because reciprocal means 1 by A. Reciprocal of A is equal to 1 by A. Suppose A, so its reciprocal is 1 by a. In the same way, I, its reciprocal is 1 by I. So we are writing here the reciprocal of I, that is 1 by I, and that one is becoming minus I. Okay, same as here we can also write, suppose 1 by minus I, that can be written as I. That's why that term is important. I and small I are the reciprocals to each other. Okay, also we can say the final lines here, that is I to the power minus 1. That means 1 by I. That one is equal to minus I. That is called the reciprocal. 1 by A, that can be written as A inverse. That's why. Okay, in the same manner, I to the power minus 1 is equal to 1 by I is equal to minus I. Last here, for the imaginary numbers, suppose we have to show that I is neither 0 nor greater than 0 nor less than 0. Now, how we can prove that? We are considering two elements, and the two elements are I and 0. If I is equal to 0, then I square, that means 0 square, is equal to 0, but I square is not equal to 0. I square is equal to minus 1. Hence, we can say here I is not equal to 0. Okay, it's the first one. That is, for I is equal to 0, we are considering. Second one, if I is greater than 0. If I is greater than 0, then I into I is greater than 0. So its multiplication with itself, that means I square is always greater than 0. But I square, that means I square is greater than 0. But I square is equal to minus 1, which is less than 0. Hence, we can say I is not greater than 0. Final one, suppose if I less than 0, okay, then we have I is a negative number. If I is less than 0, I is a negative number. Then I into I, as I is less than 0, so I into I always greater than 0, because we have any negative number into the same negative number is always positive. Then that must be I into I is greater than 0, or we have I square is greater than 0. But I square itself is equal to minus 1, which is less than 0. So the contradiction occurs. So contradiction occurs. So we can say I is not less than 0. So here, very interesting term. I is not equal to 0, not greater than 0, not less than 0. So where I belongs in the real number system. Practically, we cannot say I belongs to any real number system because I itself has been treated as an imaginary number. That's why it is not belonging to any real number system. So now some problems on complex numbers. Okay, suppose we have to simplify the following, or suppose some problems. Okay, first one is like 5i into 7. Very easy, no problem. That is, we just can write that 5i as 5 into I into 7, or 5 into 7 into I, or 35i. Okay, suppose that is the very easy first one. Second one, 3i into 4i. So here that one is 3 into I into 4 into I, or 3 into 4 into I into I. That means 3 into 4 into I square. Now 3 into 4 means 12 and I square means minus 1. So the result is minus 12. Third one, suppose 21 divided by 14i. So that is based on some fractional number. So here we are writing that is 21 divided by 14 into 1 by I. Okay, and 21 by 14, it can be divided, suppose with by 4, so that is 2 by, suppose by 7, that is 3. So it can be written as 3 by 2. Now look at the 1 by I. That means that is the reciprocal of I. So it can be written with minus I. So we are writing it as minus 3 by 2 I. That is another way. Another one problem, suppose very easy, 5 by I3. So 5 by I3 means we are writing the denominator I3, I to the power 3, as I square into I, or 5 divided by I square means minus 1 and into 1 by I. Okay. Now look at another one thing. 5 by minus I, that one is becoming. Now already we know we have 1 by I is minus I, and another one thing, 1 by minus I is equal to I. Check the reciprocal forms. 1 by minus I is equal to I here. So we can write that one 5 into 1 by minus I as 5i. Okay, so 5 by I cube is equal to 5i. Next, another one. Suppose now square root of minus 9 plus square root of minus 16. So that one we can write square root of minus I as I square root of 9 plus I square root of 16. So that one is 3i plus 4i. Now that can be added. 3 plus 4. Okay, I am writing it in that way. 3 plus 4 into I. That means 7i, as that is the case of multiplication. So that means we can say when we are writing ai, that means that is also a into I. There would be no problem. Okay. Next one, suppose another problem, 21 divided by 4, square root of minus 48 minus 5 of square root of minus 27. Okay, so here we are writing that is 21 divided by 4 square root of minus 48. So we are writing it as I into square root of 48 minus 5 into I into square root of 27. So here 21 divided by 4 into I into 16 into 3 is equal to 48 minus 5 into I into 27. That means it can be written as 9 into 3. Okay, so here we have 21 by 4 into I. That square root of 14 means 4 into square root of 3 minus 5 into I. Square root of 9 means 3. So into 3 into square root of 3. Now we can divide 4. So that one is becoming now 21 into square root of 3 into I minus here that is 15. 5 into 3, 15 square root of 3 into I. Or finally, that one is, I am not writing directly, 21 minus 15 into square root of 3 into into I. That means 6 of square root of 3 I. That can also be written in that way, or you can simply subtract 21 root 3 minus 15 root 3, that is 6 root 3 I. Okay. Now next problem. Next problem is like square root of minus 18 into square root of minus 2. Here we are writing square root of 18 as I into square root of 18 into I into square root of 2. Okay, so here we can write that is I square into square root of 18 into 2, or that is square root of 36 into I square, or square root of 6, that means 6 into I square means minus 1. The final result is minus 6. Okay, just one thing we want to say you, that never write this square root of minus 18 into square root of minus 2 as square root of minus 18 into square root of minus 2. That means we cannot write in that way. So you can say, okay, that is also the same. When we are writing square root of A into square root of B, that means square root of A into B, but that is valid only for real numbers, not for the imaginary numbers. Here that one is becoming like 36 is equal to 6, but that is a wrong case. Okay, that's why never write that one. It's completely wrong. Never write any square root of minus a into square root of minus b or square root of minus c in that way. That is the way. The main way is that one. Always transform it into the imaginary number, then do the proper calculation. Okay, and the very final one problem, like 20 by square root of minus 5. So it can be written as 20 of I square root of 5. Now it can be once again written into 1 by I. That means we can write it as 20 by square root of 5 into minus I as reciprocal. No problem, reciprocal. So it is 20 means we can write 5 into 4, square root of 5. That means square root of 5 whole square into minus I. So here the result is minus square root of 5 into 4 into I, or for easiness we are writing it as in that way, minus 4 square root of 5 I.